of the week. Really excited on our road to ETH Latam. We are having a hackathon the same days of ETH Latam, 13 and 14 of March next week. We are with Guru Debrel from Waku. Hi, Guru. How are you?
Hey guys, I'm Guru and I'm a co-contributor in developer relations at Waku. So yeah, pretty good. I just attended ETH Denver. I'm looking forward to attend ETH Latam.
For sure. I mean, I think you're going to like the change of weather at least. I mean, Denver is quite cold, and here in Central America, we are having a mild and really nice weather. So the stage is yours. I'm going to be on the backstage. I'm going to share the screen, and we are.
Amazing. So yeah, I'm really excited to visit ETH Latam for the first time. It'll be my first time in Central America. So yeah, without further ado, let me get started with the problem that we have right now. So Web2 communications do not preserve your privacy. So every time you interact with an app, or if you make an interaction online in terms of chat or any other app, most of your data can be eavesdropped by centralized stakeholders. So your social graph and your private data can be exploited by centralized stakeholders, and people can easily make mass surveillance attacks with the data that you have on the internet. Your messages that you send online are linked to your IP address, and your IP address can reveal a lot more information that you can think of. For example, it can reveal the sender and receiver details, your locations, and also the private metadata associated with your messages. So, this information can facilitate censorship, surveillance, and hinder the freedom of speech. So, for an example, if a particular service wants to block or ban users from a particular segment of the world or a particular country, it is possible because your IP address will be linked with your messages. So this is not just a problem with chat messaging, but it also extends to a lot of other use cases like gaming, marketplaces, location sharing apps, IoT networks, state channels, and anything that is, in the machine to machine or machine to human communication. So to overcome this, we've built Waku. Waku is a family of robust censorship-resistant communication protocols designed to enable privacy-focused messaging for your Web3 apps. So Waku has six main ethos. The first one being privacy, and the second one being censorship resistance, and modularity, adaptability, scalability, and the most recent innovation that we have with Waku is decentralized rate limiting. So I'll be talking more about it, but before we go ahead, I wanted to convey this important point, which is Waku is not just a chat messaging protocol, but Waku is a generalized censorship-resistant communication protocol. It can be used for implementing various use cases like gaming, marketplaces, state channels, and anything communications, which just like I mentioned before. So as we go ahead, I just wanted to recollect some history. So, in 2013, when the Ethereum white paper was released, we had something called the Holy Trinity of decentralized web, where we had Ethereum for the consensus layer, Swarm for the storage layer, and Whisper for the communications layer. So, all these together formulated the Holy Trinity of Web3. But over the years, we've kind of forgotten about Swarm and Whisper. Only the degens and the people in the space for a longer duration of time know about these technologies. But until 2019, there were not much of dedicated teams building on top of Whisper or Swarm. It was only in 2020 when Waku V1 replaced Whisper in the Status app. So, Status app was a messaging app which has been in the Web3 space for a long time. So, Waku replaced Whisper as the communication stack in 2020. And today, Waku is rapidly evolving as the communication standard for Web3. So this is a quick introduction about how Waku has transitioned over the last couple of years. And looking at Waku, we have two main segments in a nutshell. The first one being Waku protocols, and the second one being the Waku network. So Waku protocols are a way to talk with the Waku network, and they are formulated based on the various protocol specifications which we'll be looking at. So yeah, let's go ahead and For developers, you will be using Waku protocols mostly at hackathons, because you'll be integrating Waku protocols into your application. So yeah, I think this is going to be the most important focus area for you, at least in ETH LATAM. And we have different implementations for Waku protocols. We have a JavaScript implementation in TypeScript, and also a NVaku implementation in NIM. We also have implementations in Golang, some Rust bindings, C bindings, and React hooks to make your React development simple. So all these implementations are available, and you can find more about them in the documentation. But going up with the protocols, we have different protocols for different purposes. So the most so we can divide the protocols into two types. The first one being the light protocols, and the second one being the relay protocols. So light protocols are used to work in the resource restricted environments, like your mobile phones or your browsers, or pretty much anywhere where you have less bandwidth and less resource availability. So most of the hackers made use of the light protocols in our previous hackathons to build their projects. So I'll be briefing more about the light protocols specifically in this presentation. So the first protocol is light push, second one is filter, and third one is store. So these are the light protocols, and we have other protocols like relay, RLN, relay noise, and others, which you can dig into the documentation to know more about. But yeah, for the sake of this presentation, light push is a protocol that is used for sending a message into a content topic, and filter is used for subscribing the messages that are subscribing the messages from a content topic, and store is a temporary storage for persisting messages into a content topic. So these three protocols pretty much can help you discover a lot of use cases. So it's basically a protocol set that can create help you create a CRUD application with Waku. So digging deep, I'm sure you should be concerned about the world uh, content topics here. It might be the first time you're hearing it, but yeah, it's quite simple. Content topics are just the way in which the network is filtered. The whole Waku network is filtered. So you can see topics like topic A, topic B, and topic C. So all these are the content topics. And every time you send a message within the network, you'll be sending it to a content topic using the light push protocol. So there can be multiple nodes that can send messages into a content topic and also subscribe to a content topic. For example, here you can see that in topic A, we have a browser node talking to a desktop node, which is connected to a cluster. So it's pretty much like a peer-to-peer communication that happens within different filtered segments of a network. So yeah, this is content topic. And the way we represent content topics is by using this particular nomenclature, which has the application name in the beginning, followed by the version of the application, and the content topic name, and the encoding. So this is the standard that we are trying to advocate for content topics. So for an example, you can see that Super Crypto is the name of the app here, and number one is the version, and notification is the content topic name. So you can have other content topics for other purposes, like you can have messages for storing messages, and maybe push notifications for push notifications. So it's pretty much like you can have more subcategories within your content topic. And finally, in the encoding section, you'll be putting in your encoding, which is proto here. So this is an example for a content topic that follows the nomenclature standards. So going ahead, uh, I'll be revising about the protocols once again. So the protocol that is used for sending a message into a content topic is light push, and the protocol used for subscribing to the messages sent to a content topic is filter. So store protocol is used for creating a persistence for a specific content topic. So these are the three main protocols that I wanted to introduce you guys to. But yeah, you have more protocols to learn about, so make sure to dig into the documentation to know more about them. And in Waku, as you can see this message object over here, should also follow a standard, which is this form. So the first one is the content topic, which is for content based filtering. And you should also attach the payload, which is highly flexible. You can decide the payload according to your necessity. So this is a flexible part of the message object. And you can also have meta, like the additional details for providing various application specific processing. So you can also mention those attributes over here, and the timestamp on which the time of the message was sent, and also the ephemeral, which specifies the message's persistence. The ephemeral should be set to true if you want the message to persist in the stored protocol, and if it should be set to false if you don't want it to persist. So this is an example for a message object. And talking about the second segment of Waku, which is the Waku network, we have different implementations here as well. You can run your own Waku NVaku node, which is the NIM implementation of your Waku node. And you can also use the Docker compose command or the Docker container commands for spinning up your own Waku node in a Docker. And we also have an integration with dapp node. So you can just spin up your own Waku node by a matter of few clicks. So that is definitely possible. So yeah, these are the three implementations that we have for running the Waku network. And right now, the most recommended way to run a Waku network node is the Docker compose command. So you can scan this QR code for getting to know more about the instructions that you'll be following for running your own Waku node. It's just a Docker compose command that you'll have to run, and then you'll have your own Waku node running on your system in a matter of few minutes. So this is about the Waku network. If you are curious to know more about how the Waku network is architectured and what are the value propositions of the Waku network, make sure to uh, go to this research article, which is WAC RFC 64. So this QR code should help you know more about the network specifications and the architecture. So this is a quick simulation that I'm really excited to show you. So this is a real simulation of a 2 KB size message traveling across various Nwaku nodes in the world. So it starts from India, goes to Singapore, and to the United States, and ends with Frankfurt. So this is simulated using real machines across the world. So this is the performance benchmark that we are trying to achieve with Waku. We wanted to make communication around the globe seamless. So yeah, just wanted to showcase this to share about Waku's capabilities. For the hackathon, I wanted to highlight three main resources for hackers. The first one is the developer documentation, which has various guides and code snippets for building your own Waku app. And the second one is the ideas.waku.org website, which has a list of 50 or 60 project ideas or inspirations that can be built with Waku. You're not required to build just these ideas, but you're not restricted to just stick with these ideas, but you can pretty much explore any use case. These ideas are just to help you provide a reference for some cool hackathon projects that we want to see with Waku. And the third and final resource is the awesome Waku repository. So you can go to Waku's GitHub to find about this repository, which has links to all the previous projects and the workshop videos from our Waku hackathons. We have around 81 projects in the list right now from the last three hackathons that we did in 2023. So make sure to check them out, and you'll be able to get a better understanding about the judging criteria and what kind of projects we are looking at. So yeah, coming to the final section of the presentation today, it's some project spotlights. I wanted to show you some interesting projects that I personally think were built with Waku over the last few months. The first one is Block IoT, which is an IoT system that communicates using the Waku protocols. This was one of the winners at ETH India that happened last December. And this is a very novel use case because it's not chat, and it's not something that sticks just within your computer or your mobile phone, because it actually uses real world sensors and ICUs for implementing Waku. So we were really excited to see a project like Block IoT and yeah, if you are someone who works a lot with hardware, I would definitely recommend you to build something with Raspberry Pis and Arduinos. So yeah, make sure to brainstorm in those aspects as well. And the second project is Becamos, which is a privacy preserving wallet to wallet location sharing app. So right now, in the mobile phones that you use, all your locations are either transmitted through Google Maps or Apple Maps. So to make sure that your location stays self-sovereign and under your custody, you can use Becamos, which is a wallet-to-wallet location sharing app. So it's totally encrypted, so only the wallets can know about the location of the other peer who you're listening to. The third project is Battle of Cards. So as far as the Waku bounties are concerned, I think you automatically have an upper hand if you're building a game, because games definitely provide a more intuitive and more interesting interface for demonstrating communications. So if you are someone who builds extensively with Unity or some other game engines, make sure to check out some opportunities on building games with Waku. Waku can enable a lot of peer-to-peer games because Waku itself is a peer-to-peer protocol, and it's privacy preserving and permissionless. So this particular game is a multiplayer WWE trump card game built with Waku. So you can collect your cards and compete against other collectors. So this is the whole idea of the game, and we really loved it. This was also one among the winning projects at ETH India. And finally, the last project that I wanted to spotlight today is Mr. Fox, which is one of my favorites. And they are trying to build a privacy preserving and decentralized Web3 assistant. So, right now, when you use centralized LLMs or centralized GenAI models, all your prompts are linked with your identity, which means the centralized LLM can store your data for analytics or other purposes, and the administrators of this app or the creators of this app can know about who is asking what question. For example, if you're looking at a critical data, like if you have some kind of health condition, and if you are looking at it on the centralized LLM platform, the LLM platform knows that you have this specific condition, or if you are, if you want to know for a treatment about the specific condition. So it's very important to make sure that your identity and the prompts are decoupled and it's self-sovereign. So that's where Mr. Fox comes in. They are trying to make sure that your identity is preserved and is not, exposed to uh, such people who can exhibit mass surveillance attacks or mass advertisement attacks on you. So this is about Mr. Fox. And yeah, finally, some CTAs for you if you're looking to learn more about Waku as a protocol, or if you're looking to learn more about some hands-on Waku tutorials. Make sure to check on the Waku documentation at docs.waku.org. And also make sure to join our Discord, which is discord.waku.org, to stay in touch with us. You'll be getting to know about our announcements and our future updates in our Discord. You can also ask for questions to our core contributors in the support channel, and they'll be happy to help. So yeah, I think that's all about the presentation. But before we end, or before we go to the Q&A section of today's workshop, I would like to take you through some code snippets or a basic implementation of Waku within 100 lines of code. It's just 69 lines of code. So I wanted to take you through the important functions so that you can try them out before coming to the hackathon. So yes, I have the application running already. This is the application just returns Waku tutorial, as you can see over here. And if you're wondering, this is a Next.js application, which is very much similar to a React application. So I just created a function called home, and this function has a use effect hook over here. And this is the whole content of today's code snippets that we'll be looking at. So yeah, that's pretty much it. We just returned the text called Waku tutorial, which is shown over here. So digging into the functional part of it, the first thing that you'll have to do is to install the Waku SDK. the JS Waku SDK. So you can pretty much run npm install at waku/sdk, and that should install the latest version of the SDK right now. And after you're done, we have different steps, and I would love to take you through the documentation before we go there. So once you go to the documentation, you can see we have JavaScript Waku SDK over here. Go into this, and you can see the npm install command over here. So just copy paste it into your terminal to install Waku. And after that, you should also be installing protobuf.js, which is another utility library that we'll be using. So we'll be using this protobuf.js for templating the messages every time you send it to the Waku network. So this is, I'm not sure if you remember, we mentioned proto in the end of content topics. So this is an encryption scheme that we'll be following for before we push messages into the content topics. So these are the only two installs that you would need for making Waku run in your application. So after you install both these requirements, you can go here and you will find a set of guides with some description. The first guide is to send and receive messages using light push and filter. So go into this guide and you'll have a step by step instruction of how to set up your own Waku node, connecting to peers and stuff. So yeah, I followed the same procedure over here. So after importing all the required functions, we can start over here where we create and start a light node. So light node is nothing but a node that connects to the nearest relayer node or the nearest full node. So it's very easy to start a light node. This is going to be the first step in your application development process. Just create a node by using the create light node command and set default bootstrap to true. So when you set default bootstrap to true, this means that we already have a bootstrapped set of nodes available for Waku, especially for development purposes. So when you put this command in, your light node will automatically connect to these set of bootstrap nodes. That just makes your development journey a lot simpler. So you can also modify this according to your need, but for the sake of this tutorial, we are just going to put it to true. And node.start should spin up your node. So now when you go back to your application and when you go to the console logs, let me just try clearing it and refreshing it. So you can see that node has started. So another important point to see here is you'll be getting a lot of WebSocket connection failed, console errors over here or warnings over here. So make sure to ignore all these WebSocket connection failures, because this is a proof that Waku tries to discover peers and it's actually decentralized. You don't get to see all these console logs with maybe other protocols. I've never seen them, but this is a proof that Waku is decentralized and it's trying to communicate with each and every node that's available to connect to it. So that's why we have this long list of warnings over here. And after your node is started, you'll have to run the wait for remote peer command and pass the node object inside. So this particular command waits for a successful peer connection with the nearest full node. And once this is done, it should be console logging remote peers connected, which already happened over here. So yeah, that's about the second function. And the third step is to choose a content topic where you'll be pushing your messages or subscribing to. So just create a const variable content topic, and then follow the nomenclature that we discussed earlier to create your own content topic. And once you're done, you can create your own encoders and decoders. So encoders will encode the message object before pushing it into the content topic or the Waku network, and the decoders will decode the messages before it receives from a content topic. And the whole procedure for doing this is just like 5 lines of code. So initiate an encoder using the create encoder function, and then pass in the content topic and your ephemeral to true in case you want to store messages using the store protocol. So if you set ephemeral to false here, it means that the messages won't be persistent. So every time you refresh, the messages should be gone. So for this use case, I'm setting it to true. And we also set a const decoder to create decoder function and then pass in the content topic. So with this, the encoders and decoders are pretty much set. And you can also console log over here to make sure that the encoders and decoders are perfectly set. So after you do this, you'll have to create a message structure using protobuf. So protobuf is for templating the messages that you want or to be stored in the network or the content topic. So you can do this by creating a const variable again, and then use the protobuf.type for defining the message object's name. And you can add more fields to the message. For example, I'm adding a timestamp here, which is a uint64, and the sender, which is a string, and message, which is a string. So you can modify the whole template according to your application's needs and requirements. So yeah, it's highly flexible and it's pretty easy to understand. It's just adding more dot add lines of code over here, and you should be able to template the perfect message object for your use case. And after the protobuf object is set, you will have to create a new message object. So message object is just nothing but the object that you're going to push into the content topic. This is not the template, but it actually follows the template. So over here, you can see that similar to this, we have timestamp to date.now, which gets the date at the point. And then we also have sender, which is Alice, and message is hello world. So once you create the chat message, you can serialize the message. So you can also make const serialized message is equal to chat message dot encode. So this is where we encode the message before sending it. So yeah, once this is done, you can send the message using node.lightpush.send, passing in the encoder, the payload, which is the serialized message, which comes in after encoding, and then you just send it into the content topic. And once the message is successfully sent, you should be getting a console log saying message.send, which already happened over here. So yeah, I'll just run the example once again just to demonstrate you the speed at which Waku works. So I'm going to refresh, node started, remote peers connected, and the message is sent. So this is the pace at which Waku works. And yeah, I think that's pretty much it for the workshop. So I'd be happy to answer any questions if you have, or
Thank you so much, Guru. I will check on chat if there are any questions. We are getting one of our all-time highs now that this concept is like getting popular. Like we are getting back to the bull market, but we're having an all-time high in people attending these workshops. I guess people are just absorbing all this information. We have more than 180 people connected online. Everyone out there, you have any questions, please let us know. Otherwise, you can go to Taikai. This is something really important. I will just like go with this sticker, go to eatlatam.org, and in the hackathon section, just below the main header, there is a button that takes you to the Taikai platform where you need to do your registration to participate to the hackathon. Uh, Guru, let's talk about the prices, like the bounties. How much are we going to give to the hackers? If you have at hand the criteria, I know that we have 2,500, right? That's
yeah.
the amount we're going. And I mean, this is just like an extra incentive. Like the cool things about hackathon is to attend, create a group, learn. We are going to have Guru in ETH Latam in our in real life hackathon, so you can ask all the questions that you have. So it's our opportunity to learn, to also get some money, and most importantly, to participate to and start building in Web3. I have to do a disclaimer. I love bias towards what Status and Waku does. I used to work there, so this is something that is close to my heart because this is a project that is principle oriented. So I love the presentation, how you like introduce you, how you introduce us to the problem you are trying to solve with Waku status and the Logos network, because this is a suite of data, of privacy preserving tools. Just in the last minutes, could you comment briefly what is Logos? And because Waku is a piece in a bigger picture.
Absolutely. Yeah. I think I have two more things to discuss before we end it. The first one being
Okay.
introduction to status, free technology, and logos. And finally, also the hackathon bounties. So I'd be happy to brief about them before we end today's session. So I just wanted to share my screen again. I hope it's visible now. So yeah, the topmost part of the umbrella is Institute of Free Technology, which is aiming to foster innovation and defend digital liberties. So we have different entities or projects within the IFT ecosystem. The first one being Logos, which is a network state, which is a collective of network state goods, and it's a cypherpunk. It's just trying to revive a cypherpunk movement in our decentralized web. And below that we have Waku, which is the project looking at the decentralized communications part of Web3 and the network states. So we have other projects within our ecosystem like Codex, which is for decentralized storage, Nomos, which is basically a consensus that we are building with ZK encrypted network of blockchains. We also have Status, which is probably the OG of all the projects. It's been there in the space since 2017, and Status is a messaging app for instant messaging within the Web3 community. So you can expect it to be something like an alternative for Discord in the future. It's already live, and you can test it out. But yeah, we are coming up with some exciting updates for Status as well. And we also have other exciting projects like Keycard and Nimbus, which is a Ethereum client, light client with Ethereum. So all these projects together come under the free technology umbrella, and you can know more about all these in free technology. This is going to be the URL that you should go to if you are looking to know more. But yeah, coming back to the hackathon bounties for ETH Latam, we definitely have bounties worth $2,500. Uh, yeah, you can find them in Takai, detailed description about them in Takai. But just going through them in the superficial level, we have the first prize, which is $1,000, and the second prize is $500. And we also have a quadratic pool prize worth $1,000. So if you are building a successful integration with State Waku, you'll be automatically qualified for getting a piece of this quadratic prize. So any non-chat implementation of Waku is assured to win a prize at ETH Latam Hackathon. So yeah, these are the three prizes for Waku at ETH Latam.
Amazing, Guru. I mean, we have a lot of prizes, a lot of knowledge next week. Thank you for your time and this amazing presentation. I really like the introduction, the use case, and all the resources. They are out there. I mean, if I were a hacker, I would just like go to ideas.waku.org to go to that dashboard of different ideas of things you can hack. Also, we share on Twitter the awesome list of Waku, so you can get some inspiration of the 80 projects that have already participated in previous hackathons, and go there just like to get some inspiration, and definitely to check the docs. All of that is on X, on Taikai. We are going to keep sharing that information. And once again, thank you so much, Guru, for your time and knowledge.
Thanks, guys. See you in Latam soon.
See you soon in San Pedro